In this video, I will show you how to run an independent samples t-test on SPSS. So you go ahead and click on Analyze from the top panel again, and you go to Compare Means. From here, you're going to click on Independent Samples t-test. So again, you click on Analyze, and then Compare Means, and then Independent Samples t-test. In this new window that opens up on your screen, you will put your test variables in this test variable box. So I am interested in seeing whether customer satisfaction differs between female respondents and male respondents. So in this test, I'm going to put the overall satisfaction variable into the test variables box over here. And then my grouping variable is going to be gender, S7_gender. In here, I have to know what is coded as what in my data set. In my particular data set, males are coded as 1 and then females are coded as 2. I insert these two variables here and then click continue. So now I have defined the two groups that I want to compare. If here I wanted to include another variable that has more than two levels to it, such as marital status, which has a couple other options there in my data set, such as divorced, still married, single. In that case, I can actually, in the grouping variable, let me show you, insert that into the marital part and then compare group 1 and group 2, or 2 and 3, or 1 and 3, etc. I just have to insert those values here, and then my independent samples t-test will compare those two groups. As you already know, independent samples t-test can only compare two groups. That's why we're doing this here. And if you wanted to compare all of your group means, then you are likely better off running a one-way ANOVA test. So let me go back to including gender here, define groups, continue. In the options, I usually just go with the default options where my confidence interval equals 95%, and that's all I do, and then I go ahead and click OK. Here in the first table, I get the group means for both males and females. So here I can see that for gender equals 1, which is male in my data set, I have 733 respondents. Their average for saying how satisfied they are with customer service at Starbucks is 3.56. The standard deviation is 1.04. And then in the second group, which is females, I have 1,066 respondents. My mean is 3.9, and the standard deviation is 0.966. In an independent samples test, the first thing that I need to look at in the independent samples test table, which is the second table that comes up, is the Levene's test for equality of variances. So this test compares whether the standard deviation and the dispersion of the two groups are comparable, similar enough or not. The Levene's test for equality of variances has a null of both groups have equal variances. So if this F is statistically significant, we reject the null. So if this sig value, the P observed for Levene's test for equality of variances, is less than 0.05, then my Levene's test is statistically significant, and I reject the null that the two groups have equal variances, and therefore I cannot assume equal variances. So for this specific test, because my sig value is less than 0.05, I'm going to only interpret the second row of data here. So here my T is -7.033. My degrees of freedom is 1,487. My T is statistically significant. So I can conclude that females and males are statistically significantly different when they're evaluating customer satisfaction at Starbucks. So the mean for males, 3.9, is statistically significantly different than the mean for males, which is 3.56. And here I can also see that gender 2 evaluated Starbucks higher, the overall satisfaction with Starbucks higher than the gender 1. So females likely are more satisfied than males in terms of Starbucks' customer satisfaction. I can only come to that conclusion upon looking at the means. Similarly, if my Levene's test for equality of variances outputted a sig value that was higher or equal to 0.05, then I was going to say that equal variances can be assumed across the two groups, and I'm going to only interpret the first row of data for my independent samples t-test.